Assalamualaikum warahmatullahi wabarakatuh. My name is Puteri Anis binti KHALIB, and now I am going to start my presentation with IZHAR HALQI. So what does it mean by IZHAR HALQI? IZHAR HALQI means truth, clarity in tajweed, and it occurs when nun sakinah or tanwin is followed by one of the letters such as hamzah, ha, ain, ha, ghin, and kha. In this rule, nun sakinah or tanwin is pronounced clearly without nasalization, that is gunnah. For example, min al-min. The nun sakinah in min is pronounced clearly before the letter of ain in al-min. Uh, as you can see on the screen, this is the diagram of automaton construction. The program will start at Q0 and move to the next state if the letter meets nun and nun sakinah or tanwin. And then the program will move to another state, that is Q2, if the nun sakinah or tanwin meets the letters such as hamzah, ha, ain, ha, ghin, and kha. And then the final state is Q0, where the program accept the letter. At Q1, if it does not meet the throat letter, it will go back at the Q0. So that is all for the automaton construction. Move on to the next slide. This slide shows the parallel implementation of the IZHAR HALQI automaton. First, the program defines the 6 IZHAR HALQI letters such as hamzah, ha, ain, ha, ghin, and kha. It also defines the trigger symbols such as nun sakinah and tanwin. Next, the transition rule represents the DFA states. The automaton starts at the start state and moves to the IZHAR possible state when a trigger symbol is detected. If the following letter is one of the 6 IZHAR HALQI letters, the automaton transitions to the accepting state, that is IZHAR detected, and the run DFA predicate processes the input sequence according to these transition rules, while the detect IZHAR predicates checks the final state and display whether the IZHAR HALQI rule has been detected. So this implementation allows the DFA to automatically recognize valid IZHAR HALQI patterns. SWR prologue, I need to enter this command, and it shows welcome to SWI prologue. And then I need to loop my program by inserting this command. So it says true. For the test cases that I need to run is, there are 3 test cases. The first one is detect IZHAR nun sakinah made with ain, and the output will be IZHAR HALQI detected because nun sakinah made with ain is IZHAR HALQI. And then for detect IZHAR between tanwin and ghin, IZHAR HALQI detected because tanwin when meet with ghin is the IZHAR HALQI letter. That is why IZHAR HALQI detected. For the third one, for the test case, this is the detect IZHAR nun sakinah made with ba, and the output is not IZHAR HALQI detected because ba is not IZHAR HALQI letter. So that's all for the IZHAR HALQI.
Assalamualaikum, my name is Siti DAMIA binti RAZAK, and today I will be presenting about IDGHAM BIGHUNNAH. IDGHAM BIGHUNNAH is a tajweed rule in Quran recitation. IDGHAM means a merging sound and gunnah means a nasal sound. It occurs when nun sakinah or tanwin is followed by ya, waw, mim, nun. In this case, the sound is merged and pronounced with a nasal sound for 2 counts. For example, man yakulu and yawma izin yasduru. Both show idgham bigunnah because nun sakinah or tanwin is followed by ya. So the DFA has 3 states. The state Q0 is the start state where the system looks for nun sakinah or tanwin. If found, it moves to Q1. State Q1 checks the next letter. If If it is ya, wow, mim, nun, it moves to Q2, otherwise it goes back to Q0. State Q2 is the accept state where idgham bigunnah is detected. This is my prologue implementation of the DFA to detect idgham bigunnah. This transition checks whether the current character is a nun sakinah or tanween. If found, the DFA moves to the nun or tanween detected state. If the character is not a nun sakinah or tanween, the DFA remains in the start state. This transition checks whether the next letter is ya, waw, mim, or nun. If it match, the DFA moves to the accept state. If the next letter is not one of the idgham bigunnah letters, the DFA returns to the start state. After reaching the accept state, the DFA stays in the state for any remaining characters. This transition allows the DFA to identify the idgham bigunnah rule when a nun sakinah or tanween is followed by ya, waw, mim, or nun. So this is my output for the test case. First, I set the directory to my project folder. Then I load the prologue file, and I can run all test cases just by writing run test. I also can test manually using check idgham bigunnah. This word is detected as idgham bigunnah. The program tests 4 words, and the results show that idgham bigunnah detected, the first one, and idgham bigunnah is not detected, and the next one is idgham bigunnah detected, and the last one also idgham bigunnah detected. This means that nun followed by the idgham bigunnah letter, which is ya, waw, mim, and nun. This proves that the DFA correctly identifies valid and invalid cases based on the rule. That's how the system works for both automated and manual testing.
Assalamualaikum warahmatullahi wabarakatuh and good day. So I'm Nuranis binti Muhammad FAIZAL, number matric 2312-868. So in this presentation, I will explain the rule of idgham BILAGHUNNAH, how we represent it using the deterministic finite automaton DFA, and how we implement it into Prolog, and finally the result of our test case. So idgham means merging or combining, while bilaghunna means without nasalization. So this tajweed rules occurs when a nun sakina, which is the later nun with a sukun, or a tanwin, which are the vowel marks, is followed by either lam or ra. So in this case, the nun or the tanwin is merged into the following letter, but unlike idgham bighunnah, there is no nasal sound. So this is makes the recitation smoother while maintaining clarity. So understanding this distinction is important because it separates idgham bighunnah from other tajweed rules that involve nasalization. So let's look at some example in the word min ladun. Nun sakinah is followed by lam. So idgham bighunnah applies and the nun sound is merged into lam. And in mim robhim, nun sakina is followed by ra, so the rule applies again. So this example show how the rule is specific to lam and ra, and how it differs from idgham bighunnah, which involve other letters and nasalization. So to represent these rules computationally, we construct a DFA, which is deterministic finite automaton, and the DFA has 3 main states. So the start state QO is where the automaton begins, and if it detects nun sakina or tanwin, it moves to the Q1, the intermediate state. From Q1, if the next letter is lam or ra, the automaton moves to the Q2, the accept states, which means idgham bilaghunna is detected. So if the next letter is not lam or ra, the automaton returns to Q0. So once is the Q2, the automaton stays there and confirming that rule has been applied. So this DFA ensures that the detection process is systematic and consistent. So then we implement the DFA in Prolog, a logic programming language well suited for automata and rule-based system. So the program defines the inputs, which are nun, sakina, and tanwin, and the target letters lam and ra. So transition rules are written to move between states based on the input characters, and the process function recursively checks each character in the word and updating the state according to the rules. And finally, the entry point check idgham bilaghunnah converts the word into a list of characters and starts the automaton from the start state. So this program allows us to test any word and automatically determine whether idgham bilaghunnah applies. So this is more detail on how the prolog works in of the idgham bilaghunnah. So we test the program with several words to confirm its accuracy. For Min Latin, the program detected idgham bilaghunnah because Nun Sakinah was followed by lam. And for Min Rabim, the program also detected the rule because Nun Sakinah was followed by raw. However, for Min Yamin, the program correctly showed that the rule does not apply since the following letter was ya. So these results demonstrates that the program accurately models the tajwid rule and can distinguish between valid and invalid cases. So this shows the effectiveness of combining automata theory with prolog programming to formalize linguistic rules. So in conclusion, our project demonstrates how computational concepts can be applied to tajwid rules. So by using automata theory, we can represent the rules as states machine, and by implementing them in prolog, and we can test words systematically. So this approach not only helps in understanding tajwid rules more clearly, but also shows how computer science can contribute to preserving the teaching Quranic recitation. So our result confirms that the automata and the prolog program for idgham bilaghunnah work correctly, and this method can be extended to other tajwid rules as well. So I will pass to the next presenter. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila and I'll be explaining the fourth tajwid rule, which is IQLAB. So IQLAB here means to turn or to replace. This rule happens when a nun sakinah or a tanween is followed by the letter ba. When this occurs, the nun sound is not pronounced normally. Instead, it is replaced by a hidden meme sound, which with a nasal resonance called a gunnah, lasting about 2 counts. There is only one letter that triggers iqlab, and that is ba. Here we have 2 examples from the Quran. So the first is la yunbadanna. The nun sakinah is directly followed by the letter ba, so iqlab here applies. The second is anbi'uni. The nun sakinah and ba appears inside the same word, and iqlab applies. In both cases, the nun is not pronounced. It becomes a hidden meme with gunnah. Next is the DFA automation for iqlab. So there are 3 states in total. Q0 is the start state. It scans each letter looking for a nun sakinah or a tanween. When it finds one, it moves to Q1. At Q1, it checks the very next letter. If that letter is ba, it moves to Q2, the accept state, meaning that the iqlab is detected. If the next letter is not ba, it resets back to Q0. And once it's at Q2, it stays there. This is called the accept loop. This is the prolog implementation of the DFA for iqlab. The code is divided into 5 sections. Starting with the DFA transition block, this defines how the automation moves between states. When at start and the nun sakinah or tanween is detected, it moves to nun or tanween detected. If anything else is seen, it stays at start. From nun or tanween detected, if the next character is ba, it moves to accept. Otherwise, it resets back to start. Once at accept, it stays there regardless of what comes next. Moving to the nun, sakinah and tanween block, here, Unicodes are used to identify the trigger characters. Because typing Arabic directly into the terminal causes some display problems. Next is the iqlab letter block. Here, ba is defined using its Unicode code, which is 0x628. Only one letter is listed because iqlab has only one trigger. Then the process block. This is where the word is read one character at a time, recursively updating the state at each step. When no characters are left, it checks the final state and prints either IQLAB detected or no IQLAB detected. And lastly, the entry point. Check IQLAB takes an Arabic word, converts it into a list of characters, and start the automation from the start state. To check whether or not the IQLAB word will be detected or not by the prologue. So firstly, we want to check La yumbadanna. It should come back as IQLAB detected. Okay. Next, we want to check for ambiuni. Right. Okay. So next, we want to check for yambu'a. And it shows IQLAB detected. Now we want to check for Arabic words that should not return as IQLAB detected. So firstly, we want to check for Ar-Rahim. And it returned back as not detected. Next, we want to check for Al-Alami. Okay, it came back as no IQLAB detected, which is correct. And then lastly, we want to check for Al-Sirat. And it should return as no IQLAB detected.